Hey everybody and welcome back. It's Mr. Chase and today I'm doing more work with compound events. This is taking place instead of the video that you normally see with Kirk. So I'm doing the notes today instead, and we'll get right into it, okay? So follow along. If you have printed them off, that's great. Or if you have them, if you've split your screen and you're watching this at the same time as doing them on the side, that's great. I hope this whole thing with the notes is working out for you, okay? So compound events, and let's read through here. We're going to highlight some stuff and try to get into it as best we can, all right? Let's go. It says compound events are ones where more than one thing happens, right? Compound, more than one thing happens. And so thinking about their sample space can be tricky. Thinking about all the possibilities can be tricky. Let's review a two-stage event, meaning, two things happen. Okay, so number one, a coin is flipped and a needle is spun on the four-sectioned circle below. Okay, so regular something. Flipping a coin, doing a spinner, both of these things. Okay, create an organized list that shows all the possible outcomes. Okay, so let's start with heads, right? I could get heads and a 3, heads and a 4, heads and a 9, heads and 6. Okay, so I'm doing all of H's, all of the heads, and all of the numbers. I'm going around the circle, okay? Change my color and do the same thing for tails. Tails 3, tails 4, tails 9, tails 6, okay? 8 total, 4 for heads, 4 for tails. What is the probability that a head is thrown with a multiple of 3? So I'm going to circle these ones, all right? Heads, there's got to be over here and a multiple of 3. So it could be a heads with 3, a heads with a 9, a heads with a 6. So 3 out of 2, 4, 6, 8. 3 out of 8, or 0.375, 37.5%. So it's not very likely, okay? It's less than 50%, so it's not likely. All right, more than 50% makes it likely, and obviously 50% makes it exactly even, right? So there's two events. Here's the sample space, right? Remember that, guys. This is the sample space. These are all the options that you have, possibilities that could occur when doing the two events, right? Flipping a coin or spinning a spinner. Okay, as the number of stages of an event increases, so not just 2 events, but 3 events or 4 events, the sample space becomes more complicated. Let's look at a common example and introduce a tree diagram. Okay, guys, tree diagram. You've done things like tree diagrams before, like a factor tree, okay? Like if I'm factoring the number 20, 20 is 2 times 10, right? Here's a factor tree. 10 is another 2 times 5, okay? This was a factor tree, all right? Tree, just because it kind of branches out. We're going to do the same thing with a tree diagram showing the sample space. A coin is tossed 3 times in a row, and a result is noted each time. Create a tree diagram that shows the various outcomes. Then change it into an organized list. So I got to save myself some space here for organized list. I'm going to start with heads. And let's think. If I start with heads, okay, and I got to flip this coin 2 other times, after I flip a heads, I could still get a tail or a heads on the second flip. Here's my first flip. Here's my second flip. Well, then it's done a 3rd time. So I could get heads, then tails, and then on the 3rd time, I could get another tails or another heads. Or I could go heads, heads, tails, heads. Okay, let me show you the path, right? Here's the first time I flip it. Here's the second time I flip it. And here are the results of the 3rd time I flip it. Now, to get any one particular event, guys, watch. I'm going to use my highlighter. okay, I could get right here, here's one option. I could get heads, tails, tails. I could get heads, tails, heads. Can you follow that one? Heads, tails, heads. I could also get heads, heads, tails, or heads, 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 right? Now I'm going to do the same thing. I'm going to do the same thing for, oh, I was hitting the comma the whole time. Sorry about that. Now I'm going to do the same thing, but for tails. Let me see if I can go back and even get rid of that highlighted part. Yep. Good. Okay, here we go. Same thing for tails. All right, tails. That's my first event. What could I get off of that? I could get tails or heads. What could I get off of that? Tails or heads, or tails or heads. Okay, here's the first time I flipped a coin. Here's options for the second time. Here's the options for the third time. Okay, then change it to an organized list. Okay, so here's tree diagram. On the left is tree diagram. Now I'm going to show you organized list, right? I could get heads, tails, tails. That's the first one I did in yellow. Second one, heads, still going up to tails, but then I'm angling down to heads. Heads, heads, tails. H, H, T. And the fourth one, I'll write it right here. H, that's not going to work. Heads, heads, heads. For the fourth one. Okay. Now what about my tails? Okay. I could go tails, tails, tails. That's the first path right here. Tails, tails, angle down. Heads, tails, tails, heads. Tails, heads, tails. And tails, heads, heads. Where they come up with these silly words for this, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, and that's our 8 options, okay? How many total outcomes are there in the sample space? I always seem to do that. 8 outcomes. Letter C, what is the probability of getting all the same side to show up on 3 tosses? All the same side. That must mean I want to always get either heads or always get either tails. So there's 2 of those, and it's 2 out of 8, or it's saying 1/4 of the time, 25% of the time, it's not very likely. 25% of the time, I can flip a coin and get heads, 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 or get tails, tails, tails. Okay? All the other times have a combination of the 2 things, but they wanted to know just getting the same on all 3 tosses. All right? Okay, that's page 1. Pause it if you need it any time, guys. Okay? And number 2. Page number 2. Tree diagrams are helpful for 2-stage events as well as 3-stage and higher. A person tosses a coin and rolls a 6-sided die. So the 2 things they're doing are flipping a coin and rolling a die. Okay. A person notes whether the coin lands on heads or tails and what number, 1 through 6, normal dice, is rolled. Create a tree diagram to the right showing all the possible outcomes in the sample space. Okay, so I could get heads and then a 1 or a 2, 3, 4, 5, 6. That's what I could get. Or I could get tails and a 1 and a 2 and a 3, 4, 5, or 6. Okay? Find the probability of flipping tails, so it has to be on this side, and rolling a number less than 3. So there are, here's one path, a tails, then a 1, and a tails and a 2. So there's 2 options out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, out of 12. There's 2 options out of 12 that would give me a probability of 17%. That would be flipping tails, so it had to be on this side of the picture, and a number less than 3. Letter C. Find the probability of flipping heads and rolling an even number. Okay, so let me see how many paths there are. Heads and even number, there's 1. Heads and even number 2, heads and even number 3. 3 out of, and there's still 12 total options, which is 1/4 or 25% of the time. 25% of the time, I'm going to flip a coin to get heads and roll an even number. Okay, one final one of today's notes. Probability can be tricky. The more stages there are in an event. Let's look at one final example. Kirk is taking a 4-question true-false quiz for which he has not studied. Oh, come on, Kirk. Oh, you need to study. You need to study. You do too, even though you're home. He will guess on each of the 4 problems. Create a tree diagram showing all the possible outcomes that Kirk could guess. If the correct sequence is true, true, false, true, then what is the probability that Kirk guesses all of them? In other words, what is the probability he gets a 100? Okay, what can he guess on the first question? He can guess true, or he can guess false. Okay, if he guesses true on the first question, what could he guess on question 2? Well, that's easy, true or false. If he guesses true, he can go to another true or false, another true or false, and off of those is a true or false, true, false, true, false, true, false. Okay, and actually, you know what I'm going to do? I'm going to take that over to a new page so you can see all of this at the same time. Okay, right? Okay, so let's see. Where is it here? Down here, okay? It was true, then true, false, true, false, true, false, true, false. Okay, now, all of that, okay, all of that is exactly the same. I'm going to copy it. Okay, copy and paste. All of it is exactly the same, except there's one small difference. I started with a false instead. Okay? All right? Now, I got to read some of these questions. So that's the tree diagram. If the correct outcome is true, let's go in order here. True, true, false, true. What is the probability that Kirk guesses them correctly? Well, there's only one way that Kirk is going to get that. There's only one out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1 out of 16 chance. Oh, Kirk, it looks like you need to study, buddy. It's very unlikely that you're even going to come remotely close, right? I think that actually is 0.0625. You know, it's like a 6% chance that you're going to get a 100. Guys, I'm not confident Kirk's going to do well. He needs to study, and so do you. Okay? Take these notes. Use them to help you do the next couple of pages, all right? You're going to do that for homework tonight, starting with the using your math, and I will post a video tomorrow of these answers, okay? Do this tonight, using your math, and all the way down to question 3 here. Show your work. If you have to do it on a separate sheet of paper, you do. No big deal, okay? But you got to do the work. Do it tonight or do it right now, and then I'll post a video tomorrow with the answers, okay? Keep up the good work, everybody. I hope everyone's happy and healthy. Email me or talk to me on Schoology if you got a question, all right? Have a great day.